In this lesson, we're going to review all of the forms of the equation of a quadratic function. I'm going to start with the most familiar one, which should be the vertex form. Vertex form is y equals a times x minus h squared plus k. And in the vertex form, the vertex is h comma k. So a, h, and k are all going to be numbers in the equation, and then we'll have variables x and y only. So take a look at A. A is really in vertex form, although it may not look like it. If we rearrange the terms, then we have negative x squared plus 4. And so the quantity that's being squared is going to tell us what x value we have for the vertex. So if you look at the quantity that's being squared, which is just x, think about what x value will make that equal to 0. Well, for this one, that's pretty simple. If x is 0, then x is 0. So we're going to plug in 0 as one of the x values in our table of values. However, since it's the vertex, it's going to be our central value, and then we'll pick values on either side of it. So if I plug in x is equal to 0, we get y equals negative 0 squared plus 4, which gives us 4. And then let's plug in 1, 2, 3 above 0. So if I plug in 1, we have to square it and then take the opposite of it. So that's negative 1 plus 4 is 3. Plug in 2, square it, that's 4. Take the opposite, that's negative 4 plus 4 is 0. Same thing with 3. We have negative 9 plus 4, which is negative 5. Now, if we choose values on the other side of 0, that is smaller than 0, we'll get the same results, right? Because when we square positive 1 or we square negative 1, you get the same result. So they'll give us 3, 0, and negative 5. So now we can plot all of our points. Negative 3, comma, negative 5. Negative 2, comma, 0, negative 1, comma, 3, 0, 4, 1, 3, 2, 0, and 3, negative 5. And then connect those together with a nice smooth curve, and we have that nice downward facing parabola. All right, try the next one on your own. Before you begin, though, think about this. That thing that's being squared, the x plus 3, what x value will make it 0? That's going to be your vertex. Pause the video while you try this. Okay, there's the graph. You recognize that negative 3 is the value of x that makes the square equal to 0. And when you plug it in, you get negative 2. Pick a couple of values on either side. Once you get to the third value, it'll be off of the grid that we're using here. And just recognize that point in the middle right there, that's the vertex. That's the one where the square is equal to 0. All right, now let's move on. We're going to do this backwards. We have the graph of a quadratic function, and we are to write its equation in vertex form. So I'm going to start with the idea that we're starting with the equation in vertex form, which is y equals a times x minus h squared plus k. We have the vertex right here, and our vertex is h comma k, or in this case, that would be negative 2 comma 4. So if we take and we replace the h with negative 2, then we get x minus negative 2, which is x plus 2 squared, plus k, which is 4. The only thing that we lack is to find the value of a. Here's how we're going to find the value of a. We have our extra point here that has an x and a y associated with it, and that's the point negative 1 comma negative 2. So our y value can be replaced with negative 2 and our x with negative 1. Once we make that replacement, the only unknown left in the equation is a, so that's going to allow us to solve for a. So -2 is equal to, and then we have to do a little bit of arithmetic here. -1 plus 2 is 1. You know what? I'm going to correct my mistake here. Hang on one moment. I made the boo-boo on this one. The x value of this point is actually +1. All right, so let me fix that in the example. So now moving on to our arithmetic. 1 plus 2 is 3, 3 squared is 9, so we have 9a plus 4, and then we just need to solve the equation. Subtract 4 and divide by 9, and we have a is equal to -6/9, which is -2/3. When you rewrite, we need to write the equation that relates x and y. So we're just going to insert the -2/3 and bring down the rest of the equation from the first equation that we wrote. Remember that this is where we inserted the value of the vertex, or h and k. So we're just bringing that information down and then including the value of a in the final answer. So there's the equation that relates x and y in vertex form. All right, the next one is for you to try on your own. Pause the video while you do this. All right, here's the equation to this one. Now we're going to move on to a different form of the equation. Another form for a quadratic function is the standard form. Now you may be familiar with this one. Y equals ax squared plus bx plus c. Looks a lot like the equation where we solve using the quadratic formula. 0 equals ax squared plus bx plus c. We're going to move this into vertex form by completing the square. So we're going to follow a number of steps here. If a is not equal to 1, that is, if the x squared coefficient is not equal to 1, divide all the terms in the equation by a, or otherwise clear that constant. And then move the constant c to the other side of the equation to be with y. In example 3a, you'll notice that a is already 1, so we can skip step 1. And then step 2, we're going to move that constant to the other side of the equation. So I'm going to subtract 4, and then we have y minus 4 equals x squared plus 6x. Next step is to complete the square. And when we complete the square, we put a plus blank on both sides of the equation, because whatever you add to the right side of the equation where you complete the square, we need to add the same thing to the other side. Now remember, your shortcut for completing the square is to take that 6, that middle term, and divide it by 2, that's 3, and then square 3, and that's going to give us 9, so we're going to add 9 to both sides of the equation. On the left side, we have y plus 5, and on the right side, if it's factored, you have x plus 3 times x plus 3, or x plus 3 squared, and now we're almost in vertex form. We just have to subtract that 5 off from both sides, and now we have the vertex form of the equation. In B, we're going to have to include that step 1 where we make the coefficient of x squared equal to 1. Well, we can accomplish that in this equation by multiplying both sides of the equation times 2. So, multiplying both sides by 2, we get 2y equals, we need to multiply both sides by -2. So we get -2y equals positive x squared. That's what we want, is that first term to have a positive x squared, minus 4x plus 2. Now we're going to send that constant term over to live with y. And then our next step is going to be to complete the square. So -2y minus 2 plus blank equals x squared minus 4x plus blank. if you look at the middle term of the trinomial that we're trying to complete the square, that middle term is negative 4x. Take that coefficient, divide it by 2, that's negative 2, and then square it, that's positive 4. A quick note, whatever goes in that blank will always be squared. Will always be a positive number because it is squared. All right, moving on, we have negative 2y plus 2 equals x minus 2 squared. And then we can subtract the 2. And then we can divide all of the terms by negative 2. And that's going to give us a final result of y equals negative 1/2 times x minus 2 squared plus 1. All right, now it's your turn to try one. Pause the video while you do this. All right, there's the vertex form. Now let's move on to the factored form. So the factored form of a quadratic equation tells us where the zeros, or the x-intercepts, of the parabola are. And so those zeros are otherwise going to be known as x-intercepts. And when it's in vertex form, you can see both of those. Since a parabola is symmetric, if I average together those two values that are the zeros or the x-intercepts of the parabola, then we're going to get the x-coordinate of the vertex, which we knew as h in the vertex form. So let's find x-intercepts for this particular graph right here in example 2. And so we find our x-intercepts by letting y equal 0. So I'm going to take that equation and I'm going to replace the y with 0. And you can see that this is a quadratic equation that's already factored for us, which makes it really easy to solve. We just set each of the individual factors equal to 0. So x plus 6 is equal to 0, or x minus 2 is equal to 0. Of course, negative 1/4 cannot be 0 because there's no variable in that factor. So we're going to get x equals negative 6. So we have the point negative 6 comma 0 because the y is 0. And we have the point 2 comma 0. Those are our x-intercepts. So let's go ahead and graph them. And I forgot, we were going to change this one. The original had a typo in it, so let's change that to minus 6 plus 2. If we change that, then x minus 6x plus 2, x minus 6x plus 2, that's just going to change the signs of those x-intercepts. And that fits on the grid that we've got. So 6, 0. And negative 2, 0 are the x-intercepts. Now let's find the y-intercepts. And when we find the y-intercept, we're going to set x equal to 0. So y is equal to negative 1/4 times 0 minus 6 times 0 plus 2. So we have negative 1/4 times negative 6 times positive 2, and that's going to give us a value of positive 3. And so we have the y-intercept is 0 comma 3. Let's graph that point. And now we have a little bit of information about a parabola. Let's also find the vertex. The vertex can be found by averaging together the x values of the x-intercepts. So the x values are negative 2 and positive 6. Add them together, divide by 2. That's going to give us an x value of 2. And then we can find the y value by simply plugging into the equation. So our y value of the vertex is y equals -1/4 times 2 minus 6 times 2 plus 2. So that's going to give us -1/4 times -4 times +4, which is going to give us 4. So our vertex is the point 2, 4. Let's graph that one. So we have the point 2, 4, and you can see our parabola is starting to shape up very nicely. We don't need to figure this other point out, but we can certainly plot one based on symmetry. That's the mirror image of the point directly on the other side of the vertex from that point. That's enough points, and we can connect those together nicely, and we have a wonderful looking parabola, or at least a decent sketch of it. All right, so try A below on your own. All right, there's the graph in number 1. Remember that whenever you have one of your factors as x, that's like saying x minus 0. So when we set each of the individual factors equal to 0, then we're going to get x equals 0 and x equals 4. And we just really need to make a decent sketch of it. You don't need to worry too much about getting a lot of points. All right, try B now. All right, here's that second graph, and for this one, you'll notice that the y-intercept and the vertex were the same, since the vertex occurs halfway in between -3 and +3, which means it occurs at 0. All right, let's move on. We're going to do a little bit of the same thing, but backwards. So now we have a graph. We have these two x-intercepts. And so our first x-intercept is -5, 0. And remember, that's the same as in the equation r1, 0. And our second x-intercept is the point 2, 0. That's r2, 0. So we have the values of r2 and r1, which means that we can write down the general form of the factored form, which is a times x minus -5 times x minus 2. Now, just like we did when we had the vertex form, we're going to take our extra point, which is the point 0, 4. That's going to help us find the value of a. So plug in 4 for y and 0 for the x values. And we have 4 equals a times 0 plus 5 times 0 minus 2. Now we just need to do some arithmetic on the right. We have 5 times -2 is -10, so we have 4 equals -10a, and dividing a is -4/10, reduced, that's -2/5. So in factored form, the equation is y equals -2/5 times x plus 5 times x minus 2. All right, one for you to try. There's the equation for the try this. Notice that the value of a is a positive number. That means that our parabola opens upward. Quick note, in standard form, in vertex form, in factored form, this number a that sits in the front is the same exact value. So it's called the same thing in all three forms, and it will be the same value in all three forms. All right, let's move on. We are going to move equations from one form to another. So if I have an equation in example 5a where it's in standard form and I want to move it into factored form, we have to just factor. The very first thing that we're going to factor is the a value, because in factored form a is factored out. So -1/2 times x squared minus 8x, and then that will be plus 12. Remember, when you're factoring out a -1/2, you have to basically multiply all the stuff on the inside by -2. All right, so then we're going to factor x squared minus 8x plus 12. This should be easy factoring. Factors of 12 that add up to -8 are -2 and -6. And then we have this in factored form, and we're done. Right, in B, if we want to move an equation into vertex form, we're going to use the complete the square method. So let's get the value of a equal to 1, or the x squared coefficient equal to 1, by multiplying both sides by -3. So we have -3 equals x squared plus 6x minus 3. Now we're going to send that constant over to live with y. And then we're going to put a plus blank on both sides of the equation. Let me give myself a little bit more room. So you can do this as a separate step, or you can just write it in once you've moved the constant over. So 3y plus 3 plus blank equals x squared plus 6x plus blank. Now let's fill in the blank. Half of 6 is 3, squared is 9, so it's a plus 9 on both sides. And we have -3y plus 12 equals x plus 3 squared. Subtract off that 12, and then divide everybody by -3. And we have the equation in vertex form. That's the hardest transformation to do. All right, let's take a look at C. If we want to put this in standard form, all we have to do is the opposite of factor, which is to multiply out the factors. So y is equal to negative, and then let's just multiply x plus 5 times x minus 2, that's x squared. Outers and inners give us 5x minus 2x, which is plus 3x, and then minus 10. And then just multiply that -1 through, and we have the equation in standard form. Same thing when we go from vertex form to standard form. We're going to just multiply everything out. So y equals 2 times, and x minus 1 squared is x squared minus 2x plus 1. And then we can multiply by 2. And finally subtract the 5. So y equals 2x squared minus 4x minus 3 in standard form. And that's it for today's lesson.